those? Those are...
I think the dark ones are ding-dongs.
Those aren't Little Debbie's or whatever they are.
No, those are host. All right, so square root of 24. Some teachers teach it by taking out like perfect squares. I'm not a fan of that. I prefer factor trees. So how can we break down 24? What numbers multiply to 24?
Wait,
it's the tree method.
Yeah, it's the tree.
we did this while we were in?
Yeah. Yeah, we're just going to practice it. We're just going to make sure we're not rusty. So 6 and 4, okay. How can we break down 6? 3 and 2, okay, so I broke down the 6. How do we break down the 4? 2 and 2. Yeah, I scribbled it out once I broke it down. So 6 and 4, and then when I broke them down, I scribbled them out so I wouldn't use them again.
So is the one that's like most common the one that goes on the inside or outside?
So what you do is you circle the pairs, and the pair goes on the outside. And then any singletons that are left over, I underline, and those go on the inside. So I have a pair of 2s, so I'm going to put a 2 on the outside. And then I have 2 singletons, so I'm going to do 2 times 3 is 6. 6 goes on the inside. Huh? I mean, only if you're going to view it that way. Yeah. All right. 2 root 6. And if you want to double check and make sure that you didn't get it horrendously long, you can make horrendously wrong, you can make sure that your decimals match. So root 24 should be the same decimal as 2 square root 6. You won't know if you simplified it all the way, but you'll at least know if you made a huge mistake or not. So, because we're simplifying it, we're changing what it looks like, but we're not changing what it represents. It still represents the same number. If you did 12 and 2, it would work out the same way. So 24, if we did 12 and 2, 12 would be like 6 and 2, and then the 6 would be 2 and 3. So you'd still have a pair of 2s, and then you'd still have a 2 and a 3. Why wouldn't you do what? So a 2 would just be 2 times 1. And anything you could simplify down to a bunch of 1s. But if I take a bunch of 1s and put them as a coefficient in front of something, you don't even really need a 1 in front because multiplying by 1 doesn't change anything. So that's why we don't break down to 1s.
So even doing 3 and 4 from 12 would eventually get you down to the same.
Even if you did 3 and 4 from the 12, it would eventually get you down to the same thing. So they call this like a prime factor tree because your goal is to get it down to prime numbers. And so like 2 and 3, those are prime numbers. So that's your goal. Like 6, we continue to break that down because 6 is not a prime number.
Wait, so why can't you... Oh, hold on. You can't get the pairs if they're on two separate ranges, right? Like the 2...
Yeah, so the 12, I broke it down, so I'm not going to use the 12 again. The 6, I broke it down, so I'm not going to use that again.
So I'm saying, like, you see the 2 that you got from the 12?
Mm-hmm.
And the 2 you got, like, on the...
You could make this a pair. Yeah. All that matters is that they're the same number.
Okay, so that's...
Yeah. Mm-hmm. Okay, let's try another one. Let's do the square root of 80. So what are 2 numbers that multiply to 80? 10 and 8. Okay, and there's not a specific right way to do this. So if you did 2 and 40, we're going to get the same answer. You can break it up multiple ways. So how do we multiply to get 10? 5 and 2. Okay, I'm done with the 10. How do we multiply to get 8? 4 and 2. 4 and 2. Okay, and then how do I multiply to get 4? 2 and 2. Okay, get rid of the 4. So we have a pair of 2s and a pair of 2s. Yeah, so if you have multiple pairs, you just multiply them together. Kind of like here we had a single 2 and a single 3, so we multiplied them together to get 6. If you have a pair of 2s and a pair of 2s, you say 2 times 2 is 4. And we have a leftover 5, so that's 4 square root 5. And if we want to make sure we didn't make a big mistake, we can check our decimals. So square root 80, there's that decimal, and then 4 square root 5, same decimal, so at least I didn't make a huge mistake.
Wait, so the only reason you would double it on the outside of the square root is if you have 2 pairs?
So if you have multiple pairs, you just multiply them together. Now, if you are doing this and you end up with only pairs, you have pairs of every single thing you did, it means that you accidentally did this process with a perfect square and you just didn't recognize that the problem you were doing was a perfect square, okay? So for example, let's say that we were doing 16 and we forgot that 16 was a perfect square. Let's break down 16. We know it's a perfect square. We know the answer's 4, right? But let's break it down. So 8 and 2. And then if you break down 8, what do you get? 4 and 2, okay? And then if you break down 4, what do you get? 2 and 2. And so what happens with this, because it's a perfect square, it only has pairs, it has no leftovers. So here, if you had only pairs, you'd be like, okay, 2 times 2 is 4. I have no square root sign because I have no leftovers. So if that happens to you when you're doing a simplifying problem, all that means is that you ran into a perfect square and you just didn't recognize it was a perfect square when you did the problem.
So the reason of this is to figure out if it's a perfect square or not?
That's not the reason for it. The reason for it is to simplify. This is just the process for simplifying square roots, kind of like there's a process for simplifying fractions. The reason we do this is to make these smaller radicals so that they are more manageable. So you might be doing it because maybe you want to add 2 radicals together, like this is a 4 root 5. Maybe you also have a 2 root 5 and you want to add them together and say, oh, I've got 6 root 5, and I wouldn't have recognized that if I hadn't simplified them. So it's beneficial because root 80 is kind of cumbersome. It's a bigger number. 4 root 5 is smaller numbers. That's going to be more comfortable to deal with. That's the benefit of simplifying. When you get into higher math, we don't simplify as much if it's the final answer. So we put them into smaller numbers. We teach it to you in math 2. And then to be honest, a lot of times in higher math, they don't even care if you do this unless you need to in the problem. Otherwise, you would skip it. What was your question? So when I do the zoo, I only do it for actual mistakes as opposed to, oh, you did something that's not a mistake, it's just good practice. So if you like, something that I would make an animal out of is if you like switched and you put the pairs underneath and you put the singletons out in the front, that's an actual math mistake that I would put as an animal. So the animals are only for actual mistakes.
Can you tell us what mistakes have been made?
I don't think the one that I have for radicals is if you're like solving and you don't put the plus minus in the front. Other than that, I don't think I have one for radicals.
Which one's the one that's turned around?
Honestly, I don't know. I just couldn't reach that one.
Is there like a rating system for like the worst?
Oh, I thought you were like turning them around as we made.
No, no, I just couldn't reach it. I just didn't feel like I had to get up on a desk to do all of them, and then I just got lazy. All right, let's do another one. Okay, square root of 245. Square root of 245. So how are we going to break this one down? What number do you definitely know goes into it? 5. Okay, so I'm going to do 5 times something. I'm going to use my calculator to kind of help me out with that. Ooh, 49. Why did I like 49 being in there? It's a perfect square, yeah. And what is it a perfect square with? 7. So that's 7 times 7. So there's our pair right there. And then here's our leftover. And so what does this simplify to? 7 square root 5. Okay. Okay, now we're going to try one that has a coefficient in front of it. So we're going to do 5 square root 20 and see how you handle that if it's got a number in front. Okay? So before we deal with the 5, we're going to work with the 20. So cover up the 5. if I look at the 20, let's break the 20 down. 2 and 2 and 10? Okay. So 2 and 10, or you could do 5 and 4, whichever way you want to do it is fine. If you did 2 and 10, how would you break down the 10? 2 and 5, or 5 and 2. Okay, so we have a pair of 2s, and we have a leftover 5. So from the radical, we have 2 root 5, okay? And then what I'm going to do is I'm going to drop down the 5 that was in front. Now, the 5 that was in front was written right next to it. So what operation is that if you write them right next to each other? Multiplication. So 5 times, all right? Now, what would I have if I multiply these together? 10. So it's 10 root 5. Yeah. Yes. Okay, how are you guys going to feel if I put some variables in there? All right, let's do it. That was just the affirmation I needed. Okay, let's do... Okay, we're going to do 7 root 54 x to the 5th. 7 root 54 x to the 5th. Okay. I'm going to ignore the x to the 5th for a second. I'm also going to ignore the 7. Let's deal with the 54 first because we know how to do that. So 54 is what? 6, yeah, 6 times 9. Okay, and then 6 is 2 and 3. 9 is 3 and 3. Okay. Okay, and then x to the 5th, if I was to break that down, how many x's are being multiplied together? 5. 1, 2, 3, 4, 5. Okay, so what we're going to do now is we're going to go through and we're going to circle all of our pairs. So I've got a pair of 3's, I've got a pair of x's, I've got a pair of x's, and then I'm going to look at my leftovers, my little singletons. Because it was x to the 5th, so I wrote down 5 of them. Because there's 5, right? So 2, 2, 1. Okay, so what I'm going to do now is I'm going to multiply my pairs together, and then I'll put my singletons underneath. So I've got 3 times x, which is, okay, so 3x squared, okay? And then what's going to be underneath? 6x, okay? And then I also had a 7 in the front. Bring the 7 down. Okay, so what do I have now?
7 times 3x squared. Or that.
There we go.
Okay.
So did the variable make it that crazy?
Oh, it's a 3 in front of the x.
Yeah. So the variable works out the same way as the numbers did. You just, okay, we're looking for pairs. All right. Let me give you another one to try.
So explain why we squared it.
It was a pair of x's and a pair of x's, so we had x times x squared. 3 times x times x. 3x squared. Yeah. Okay, we're going to do -5 square root 175 x to the 3rd. Yeah, we'll do it just like that. Well, you could break this down with a 5.
Well, yeah, but
So if we did 5 times something, what is it multiplied by?
35.
Yes. So it's 5 times 35, okay. And then what do we do? 5 and 7. Okay.
I think I got the answer.
And then the x's are, how many x's do we have? 3. There's only one pair. And then we have leftover, leftover. And what goes underneath the radical? 7x, okay. So if we simplify that, we have the negative 5 from here, and then the 5, and then the x. So negative 5 times 5x, and what do we get in the front? Negative 25x times the square root of 7x. Okay, how did we do?
I think, how did it square? I thought it was x squared.
So we had a pair of x's and one left over. So since we have one pair, we had a pair of 5s and a pair of x's. So since we had one pair and one pair, we did 5 times x is 5x. Okay, let's try this one. We're going to do... Can you handle 2 variables? Anybody? Can we do 2 variables? Okay. X to the 6th, y to the 4th. Whew.
Whoa, that's a little.
I know, that's crazy. Okay, let's give it a shot. That's an even number. I can divide it by 2. You can do 28 and 4. So if you did 56 and 2, then your next one would be, you could do 7 and 8. And then if you did 7 and 8, you would have, okay. And then we would have 2 and 2, okay. So we have a pair of 2s and a pair of 2s and a leftover 7. Okay, and then what should I do?
You gotta do the x's right on.
So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay, and then what should I do?
Circle your pairs.
Circle pairs. Okay. So
Outside.
Whoa, no.
You don't?
7 years
Now
old.
down.
Oh, gosh darn.
okay, so 7 goes on the inside. And then what do we do on the outside?
There's 4.
So 2 times 2 is 4. 4 times... We're going to do 4 times 3. Okay, so 3 times 4 on the outside. And then what do we get for the x's?
Cube.
X to the 3rd. Okay, and then
Y squared.
y squared. Okay, so 12 x to the 3rd y squared root 7. Whew,
That's too much.
Yeah.
wild. Okay, how are your brains feeling with this? Feeling pretty good? Okay. I'm going to say no homework tonight. Enjoy your weekend. If you have any missing work to make up, go ahead and do that. We'll work more on simplifying radicals on Tuesday. All right? You're welcome so much.